Already did. I collected it. Okay, guys. So we're looking at the notes for Friday, October 7th, section 1.4. So here's our whole goal with this, guys. We want to be able to find any intercepts we have, as well as any asymptotes, and we want to be able to use the limits to graph the function. So we really don't want to be using a graphing calculator. You can use a graphing calculator to check your answers. Alright. So, first of all, how do we find an X intercept? Do you know how to do that? Plug in 0 for Y. Solve for X. The reason we want to find these intercepts is because they help us to give a more accurate graph. How do we find a y-intercept? You got it. Now, we've been talking about how to find limits as x approaches infinity. And everybody did pretty well with that. But without knowing it, when you are finding those limits as x approaches infinity, you are actually finding the horizontal asymptote. The horizontal asymptote is a helpful thing to know when we're graphing, because it's going to be a value that the function is approaching as x goes to infinity. So I'm going to show you both ways to find the horizontal asymptote. Here's a rule. If the numerator and denominator have equal degrees, then the horizontal asymptote is y equals a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. Let me show you an example of that. That would be as if I have the function, let's say f of x equals 2x plus 1 over 5x minus 1. See how the degrees are equal? So the horizontal asymptote here would just be what? Y equals 2/5. We were finding those horizontal asymptotes by finding the limit as x goes to infinity. To do it that way, I would divide everything by x. So 2x over x is 2, 1 over x is 1 over x, 5x over x is 5, and 1 over x. And then I would plug in infinity. Well, what is any number over infinity? So see how we would end up with 2/5? So no matter how we do this problem, we're going to end up with that asymptote of y equals 2/5. So now we have two ways. We can double check ourselves to see the horizontal asymptote. Now, if the denominator degree is greater than the numerator degree, here's a rule you could memorize. The horizontal asymptote will always be y equals 0. That would be an example like this. Suppose we have the function, say x plus 1 over 2x squared plus 3. Well, I look at the denominator degree, it's larger than the numerator, so therefore I should have a horizontal asymptote of 0. That means the limit as x approaches infinity should be 0. So I would go through, I would divide by x squared. X over x squared is 1 over x. 1 over x squared is 1 over x squared. 2x squared over x squared is 2, and 3 over x squared. Then I would plug in infinity. What's 1 over infinity plus 1 over infinity squared? 0, so I'd have 0 divided by 2, and 0 divided by 2 is just 0. So see how that rule works both ways. So we can either memorize this rule, or we can find the limit to infinity. You have to figure out what's best for you. If you're a person who's great at memorizing, memorize the rules. Then you also can quickly find the limit as x goes to infinity. If you're not good at memorizing, then you want to do the limit as x goes to infinity. And then you would also know that limit as well as the horizontal asymptote. Alright, find x and y intercepts, holes in the graph, horizontal asymptotes, vertical asymptote. Use one-sided limits to evaluate the limit as x approaches the vertical asymptote, and then sketch. So the first thing we're going to look at is the function, and we're going to identify the vertical asymptote. Brandon, can you tell me the vertical asymptote? -4, it's whatever makes the denominator equal 4. Or equal 0, I mean. 4. I still only told you the answer. So it's x equals 4 is a vertical asymptote. So we're going to go ahead, graph the vertical asymptote. Okay. Now we want to see if there would be any holes in the graph. Okay. To find holes in the graph, there would have to be something that's a factor in the denominator that cancels with the numerator. We do not have that, so therefore there will be no holes in the graph. The horizontal asymptote, we can use those rules we just talked about up above. When the power in the denominator is higher than the power in the numerator, what is that horizontal asymptote? 0. So this is going to be y equals 0. If you did not remember that, then you would need to do divide by x everywhere and do that method. X and y intercepts. I'm going to plug in 0 for x. That's going to find my y-intercept. If I plug in 0 for x, I get -2 over -4. That's 1/2. I'm going to plug in 0 for y now. So plugging in 0 for y, we get this. I'm going to multiply both sides by x minus 4. These cancel. Anything times 0 is 0. Can 0 ever equal -2? Nope, so we do not have an x-intercept. So now we have to find the limits in order to know what's happening to the graph. Is the graph shooting up? Is it shooting down? What's going on? So we're going to find the limit as x approaches that vertical asymptote of 4 from the left side. Tell me a number, Teresa, that's to the left of 4, just a little bit. Well, that's pretty far away. I want really, really close to 4. There you go. 3.99 is good. So now I'm going to plug that into my function. So I'm going to have -2 over 3.99 minus 4. So that's going to give me -2 over -0.01. What do we know the answer has to be as we approach a vertical asymptote? Exactly. So if I have a negative divided by a negative, what does this answer have to be? Positive infinity. So as I approach 4 from the left-hand side or from the negative side, we have to be approaching infinity. Now we want to check as we approach 4 from the positive side, because the function could shoot up or it could shoot down. So I'm going to check something a little larger, 4.01. Now watch how I'm going to do this. The numerator is negative, the denominator is positive. I don't even care what the actual numbers are, right? Because I know the answer is infinity or negative infinity. So save yourself some time and just figure out whether it's positive or negative. Questions? All right, let's do number 2 now. Maddie, what's our vertical asymptote? Good. How do we check for holes in the graph? Mary Beth, what do I need to do to check? Right, so I'm going to factor out a -6 actually. And then I'm going to check to see if I have common factors, and I do not. So there are no holes in the graph. For the horizontal asymptote, I'm going to look back at my original function and I'm going to look at the powers. The powers are the same, aren't they? So does anybody know what the vertical asymptote's going to, or horizontal asymptote's going to have to be? Right, so it's y equals -6. I'm going to have to plot that. And then I'm going to plot this one as well, my vertical. Okay, now x and y intercepts will help support whether it goes like this or like that. So I'm going to find those. I'm going to plug in 0 for x. And I can either use the original or the factored form. I'm just going to use the original. It's easier to plug into. You can do either one. 0 plus 6 is 6, divided by 2 is 3. I'm going to plug in 0 for y. So when I plug in 0 for y, I've got this. I'm going to use my factored form because I'm thinking ahead that that's going to be easier. I multiply both sides by x plus 2. So anything times 0 is 0. And so what's that going to be then? What makes that equal 0? 1. Now, by using common sense, I know what's going to happen in this region here. It can't be down here, can it? Because there's no y-intercept down there. So it has to go up here. Don't always get so stuck on using rules that you just don't stop to think of it, just, using common sense. So I already know this answer here has to be infinity. I'm not going to bother figuring it out. I can see it has to be that. As I approach -2 from the left, I'm going to check -2.01. And watch how quickly I can do this. I have -6, that's negative. -2.1 minus 1 is negative. -2.01 plus 2 is negative. I am not finding numbers anymore. I know the answer has to be positive or negative infinity. I have a negative times a negative divided by a negative, so what's it going to be? Negative infinity. So we start off, I had you find it, the actual numbers, but now I want you to get away from that because it's so much faster just to do it this way. Alright, let's do example 3. Vertical asymptotes. Before you can find these, you have to do your factoring, so we're going to factor the denominator. And before we find the vertical asymptotes, we want to check to see if anything cancels. Taylor, does anything cancel? Okay, so those cancel out. So Taylor, what's our vertical asymptote then? Good. Let's go ahead and plot that. Okay, what about holes in the graph? Emily, do we have any holes in the graph? What makes this equal 0? -4. So I'm going to have a hole in the graph at -4. Now, here's where people mess up, because they plug -4 into the original, and they get 0 over 0. You don't plug that into the original. You have to plug it into the factored form. This is the one place you have to use the factored form. So 1 over -4 minus 4 is going to be -1/8. So I'm going to try to show that there's a hole in the graph there with an open dot. For the horizontal asymptote, I'm going to go back to the original or to the factored and cancel, it doesn't matter. And then where are we going to have a horizontal asymptote then? Chase, do you know? Put that in there. I'm going to find any intercepts. I'm going to plug in 0 for x. Here we'd want to go with our, it doesn't matter, you can go either way on the intercept. The only place you have to use the factored version is when you're finding the hole. Everything else you can do either one, whichever's easier. So I'm going to plug into the factored, it's just quicker. And then I'm going to have to set y equal to 0, and I'm going to use the factored version, because very quickly I can see this, guys. Really, all you have to look at is, does the top ever equal 0? Is it possible for the top to ever be 0? No. So I have no x-intercepts. So I'm going to go ahead. Now this is kind of misleading. This is asking us for the limit as we approach -4. But they're just seeing if we can figure out what this answer is here at -4, even though there's a hole in the graph. We need to finish graphing by finding limits as x approaches 4 from the left. And as x approaches 4 from the right. And again, I'm not even going to actually evaluate this. I'm going to do 3.99 into my factored version because it's easiest, the simplified version. So I have a positive on the top, 3.99 minus 4 is a negative. See how quickly we can do that. And then we also have to figure out from the other side. So to figure that out, I'm going to have to do 4.01. So plugging that in, I'm going to have a positive on the top, a positive on the bottom, so that's positive infinity. So here's the way it's going to look. Now, to answer this question, as I approach negative 4 from the left and the right, what's the y value we're approaching there? Negative 1/8, right? So we do still have a limit. Even if there's a removable discontinuity, there still is a limit there. There's still a value that we're getting closer and closer to. All right. I want you to think about this review for a second. See if you can figure out where you are going to plug everything in. This is what was on your quiz. Quiz grades are on half, but I'm going to give them back to you on Monday because I still have several people who need to take it. So try these 5. Do them pretty quickly. Noah, what'd you put for letter A? $13. Do we agree with 13? Yep, that's right, isn't it? Because we had to check, we just plug 4 into the top function. We don't have to do 3.99. It's not a vertical asymptote. The only time we have to plug in 3.99 or 4.01 is if it's a vertical asymptote. It is not. Okay, so what about letter B then? Sean, what'd you put there? Do we agree with 0? Yep, that's right, isn't it? We have to plug into the part B function. Here's the A function, here's the B. This is from the positive side, which is the greater than side, so we plug in right here. What about letter C then? Erica, what'd you say? And why is that? Correct. Very good. And then what about letter D? Lydia, what'd you put there? 0. Do we agree? That's correct, because this is where it's equal to 4, so we plug into this one. And then discuss the continuity of g of x. Well, it's continuous except for where? Yeah, Raymond. I'll do it right now. To find the general limit, the limit from the right and the limit from the left must be the same. And if they're not, there's a big gap. And so therefore there's no y value that we're approaching, so the limit does not exist. The continuity, we would just say that it's continuous except we have a non-removable discontinuity at what x value? At x equals 4. Okay. Very good, guys.